Hello, this is Scholar Strife, and today we'll be looking in Algebra 2, we'll be looking at the natural number e. E, also known as Euler's number, or the natural base, as they would call it. It's kind of like pi and stuff like that. It's irrational. And it was discovered as n goes to infinity. We're looking at this, 1 plus 1 over n to the nth power. As n gets incredibly high, they approached this number, which is 2.715281525. Now, I'm not going to go into the history of E, not that much. We're just going to go over how we kind of work with it and use it. So here we go. Simplifying expressions. Same exponential rules that we used before still apply. Okay. So if we're multiplying some exponents here of the same base. So the base here is E. And we have 2x and 3 plus x. We just add them together. So for example, if we had 2 to the 3 times 2 to the 5, this would be 2 to the 3 plus 5. So in this case, e to the 2x plus 3 plus x. So that would be e to the 3x plus 3. Okay, part B. 6 divided by 8, that could be reduced into 3 over 4. Now what do we do with this e stuff? Same thing. 3 squared over, let's use a different example. 3 cubed over 3 to the first is the same thing as 3 to the 3 minus 1, which is 3 squared. In this case, we have e to the first here. This will be e to the 4x minus 1. And then part C, this is the same thing as the cubed root of 8 times the cubed root of e to the 9x. So the cube root of 8 is 2. And then remember, we can change cube roots into fractions. So this is e to the 9x to the 1/3. That means the cube root. So exponent to exponent means you multiply. So 2 to the e to the 9x times 1/3. So we get 2e to the 3x. All right. Let's go back to banking. Compounded interest formula. A equals P times 1 plus R over N to the NT. A equals P E R to the T, also known as PERT, where P is the principal, which is your starting amount. R is the interest rate. Make sure you put it in decimal, not percentage. And time for t in years. So let's go ahead and use this. So we have two formulas here. One is for, well, our compound interest formula from before, and then continuously compounded, so you do it continuously every day. Yeah, you continuously do it every day, compound it, boom, boom, boom. Here we go, you deposit $4,000 in an account, so that's our P. That pays 6% annual interest, compounded continuously, so make sure you look for these words, because if it's compounded annually, monthly, continuously, then you'll use the top formula. If it's compounded continuously, then you'll use PERT. So this R value here, remember, is 0.06. So let's look at this formula here. So we're using PERT. So it's P times E to the RT. So this is 4,000 times E to the 0.06 times 1. Put that in your calculator, and you'll get 4,247.35. Okay. So now we're going to put 5,000 years in, so nothing's going to change except t, which is now 5. And that'll give you 5,399.44. And then after 10 years, plug 10 into the formula, 7,288.48. So you start off with 4,000. You got $247 after the first year. After 5 years, you got 1,005 or 1,399. Then after 10 years, you haven't doubled your money yet, but it's getting there. It's getting close. That's why we always want to keep adding money to our bank accounts. The more money we have, the more interest we get. Well, I meant get the same percentage rate, but we get more money from our interest. So let's compare our little compound interest formula to our continuously compounded interest. So remember, this one is A equals P times 1 plus R over N to the NT. Okay, and then over here we're using PERT. So make sure you don't get confused on which formula you're using. A and B is using the left formula, and C is using PERT. Okay, so we're depositing $100. That's our P value, plus 1 plus 0.05 for our interest rate. It's compounded once a year, so N is 1 here. And so 1 times 10 years. So this will give me 162.89. All right. Monthly, N would be 12. Plug all that same thing in the formula, and we get 164.70. If we do it continuously, so this would be 100 times E to the R, which is 0.05, times T, which is 10. And that'll get us, let's see, 100 times E to the 0.05 times 10, or 0.5. And that'll give us about 164.87. So, look how closely those are all related. It seems you want to compound as often as you can. I'm not exactly sure, but the banks use something similar to this. Not exactly this, because there's a lot of different factors, like where they invest your money and how they get their money and how you gain money. It's a bit more complicated than this, but this will, if you ever go into that, this will help you out. All right, have a good day.